inverse. Just using plain old sine inverse to solve for b. You guys double check me. Was it 34.753?
Yes.
I feel so confident.
Now, if you were going back and forth, and if you were like, okay, 34.753, if you did 180 minus sine inverse, since you have it in your calculator, or you had it in your calculator right then, you should have also gotten your other angle possibility for angle B to be 145.247 degrees. Is that making sense?
Yeah.
Okay, now, angle C, how would you find, just mathematically speaking, how would you find angle C?
You add the angle and then subtract the 180.
The one that's given, good,
You subtract
to the one that you found and subtract from 180, exactly. So, the first one I would have gotten for angle C would have been 125. Good, 0.248. Now question, does it make sense that these three angles make a triangle? Yeah, they all add up to 180, right? Okay. When you did angle C, doing 104, is it 7? One rounded?
Because 7 plus
125, oh it is 0.7. It's 7.4. Now if you rounded, now pause, wait. If you rounded early, every now and then, which this is not the case in this one, but if you round early on this one, do you think in solving for the next one, should you use the rounded version or the non-rounded version?
non-rounded.
Okay, non-rounded. Now in this one it actually looks the same either way. But if for any reason I had rounded up in this one, just be careful. You don't want to introduce error, right? So you can round for an answer, but use the unrounded version when applying to a formula. I'll show you that in just a moment because it might make a difference for side C. Now over here we did 145.247 plus the 20 degrees subtracted from 180. I think you end up with 14.753.
Yeah.
Good. Okay. Now, pause. Does it make sense that these three angles make a triangle?
Yes.
Yeah, they all add up to 180. They're all less than 180. None of them are negative. That would be really weird. So we're good. So they are both possible ways of finishing the triangle given these three pieces. Now, side C. How do you guys set up a formula in order to solve side C? Okay, 3 over, careful, sine 20, right? Using the most precise angle on side as possible, which we were given 20, we were given 3, so don't go using, I wouldn't say, the 34.753, that's rounded, that has error, equals, I don't know side C, over sine of, why am I going to put 125.2474 ... What am I trying to prove to you?
Accuracy.
Accuracy. You want to keep it as accurate as possible. Can't you just scroll up and get whatever answer you want? If you have an old calculator, can't you hit second enter to go get whatever future ones or higher ones there are? Second enter. It works for you too, I think, doesn't it? Okay, so then when you're going ahead and plugging in and solving, we know just to multiply that sign of the nastiness up above, right? By 3 over sine 20. I like my alpha y equals to make it all nice and organized. 3 times sine of the 125.247. You guys making the second entry thing work? Might be easier to retype it at this point. It's too high up there, but it should work. I ended up with 7.163. Do you guys agree? Pause. If you had 7.162, that means you rounded early and you shouldn't have. The only answer would be 7.163.
Did you cross multiply the attachment?
Well, technically, I want to solve for C.
Yeah.
So division, I can just multiply to the other side. So I did 3 times this guy divided by that guy.
Okay.
Which ultimately would be cross multiplication because you would have 3 times, right? These two would be multiplied. And then you would have to divide that sine 20 later. So yeah, cross multiplication isn't a bad way to go. I just simply multiplied the sine 125.2474, etc. to the other side. Now in this one, basically the very similar idea, except the only thing that's going to change is what angle I'm using. Now I'm using sine of 14.7525 ... What am I trying to prove?
Accuracy.
Don't round. Don't use rounded answers to find other answers, right? So I'm gonna go ahead and go steal my same expression from up above, but instead of using the angle that I did use, the 125, I'm gonna go use the 14 one. Delete the other one. Delete, and go. 2.234. And technically, kiddos, if you were teaching an elementary class, you could just give them these pieces, give an angle with this cutout, and say, hey, use these lengths to make a triangle. Some of them would have made the triangle that's more cut in, which would end up having a bigger angle C and a smaller angle B, a little angle B and a big angle C, an acute and an obtuse angle. Some of them would have made a triangle that way, but others might have made a triangle the other direction, as long as they didn't all cheat. If you all cheat, then there's no creativity left, sadly. So you don't realize there might be more than one answer. But if they worked independently, then some would have probably made a triangle this way, some would have made a triangle that way, where angle B is bigger, a larger acute angle, and angle C is smaller, which would be a bigger B. Oh, nope, it's not acute. It is obtuse, that makes sense. A right triangle would cut there. Anyway, B is bigger, C is smaller, there we go. Now, let me show you another ambiguous one. Let me not draw one picture and see what you guys can do with it just using the formula. What if I was to give you, oh, hey, there's a whole table you can memorize. We'll come back to it.
No.
You don't have to memorize it as long as you get the idea. Here's a triangle. There is a picture drawn. But I want you guys just go straight to the formula. Go straight to law of sine. Don't be thinking about swinging necessarily, swinging the side back and forth and how many possible triangles you can make. Just take the angle A, the side B, and the side A. How would you plug into law of sines? We thought it was pretty easy yesterday. And where would it lead you? Not gonna give you super long. I'm not gonna give you super long. Guys, in your law of sines, what's missing? A side or an angle? Alright, maybe it's working. Okay, you guys plugged in the law of sines. What did you find out?
Sine 42.
Okay, sine 42. Jonathan, any reason in particular why you're putting the angle on top?
So you show the bottom.
What's not in the bottom? I like it, but what's not in the bottom?
Unknown.
What's unknown then?
The B.
You're missing the, you can't do C yet. B. Okay, so pause. Just by plugging in the law of sines, just by plugging in stuff, don't you realize the angle's missing? And that's weird. We like it when the side's missing. That's easy. When the angle's missing, how do you need to solve?
You multiply outside with the sine inverse.
Multiply 12 to the other side, but then, as Andrew was saying, you have to somehow get an inverse sign in there, right? So pause. We just talked about if you're using inverse sign, what do you need to be careful of and consider? The possibility of having two cases. The nice thing is, guys, the math leads you there. You don't even have to be looking for SSA. You go to plug into law of sines and you're like, stink, there's an angle missing. Stink, I have to use sine inverse. Oh, that's right, sine inverse. Don't just try sine inverse. Also try, what else are we going to try for case 2? 180 minus sine inverse. Okay, ready, set, do the same thing, go.
Do it, please.
You guys are doing great. Let's do it again. But now with new information.
Why do we do the 180 minus 2?
Because the sine inverse button in our calculator only gives us one answer. But the unit circle says, well, technically sine would be a positive in the first quadrant, which is what the calculator gives us. There can also happen in the second. Now, if it was cosine or something where it's happening in the third or fourth, the angle's way too big for a triangle, but for sine, when you're in the second quadrant, as long as an angle's less than 180, it could be a part of the triangle. So I have to watch out for that second quadrant angle and see if it's possible or not. Does that make sense?
Mr.
Yeah,
I have a question.
yeah, I'm listening, go ahead.
So B would be the sine inverse of both sides.
Because the only way to solve for B is to take sine inverse of both sides. The reason I'm not showing that, Caro, is because technically that would be automatically case 1. Case 2 says, yeah, sine inverse, but 180 minus, so that's why I'm not actually showing that before the two cases. Now, as you guys are doing angle B, question, what do you get for the case 1 angle B? Just using sine inverse.
21.406.
Okay. Now, when you add that to the given angle A and subtract from 180, what would be its corresponding angle C? So angle B has to now join forces with angle A to 42 degrees, 180 minus,
158.594.
hold on, that's too big.
116.
You forgot to subtract the 42. So subtract the 42, then you get, Jacob, 116.
.594.
You guys agree, 594?
Yes.
Okay, now, before we go any further, hold on, pause, other side. What would 180 minus sine inverse be? 159.594? 58, thank you. I heard it wrong, sorry. 158.594. Okay, how would you find angle C, the corresponding angle C? Yeah, so 180 minus 42 minus 158.594, and what do you get? Negative what?
20.594.
Why should that negative tell me not this time? I can't have a negative angle in a triangle, or another way of thinking about it, if I add 158.594 plus 142, isn't that 190? Oh, it's more than 180, that's not a triangle anymore.
That's why there's a negative.
Yeah. So pause, think about it. Does this one make sense? Yeah. Does this one with a negative C?
No.
No. Which means, what type of situation is this? Is there any ambiguity? No, there's only one possible triangle and this is it. Why? Because the third side, or I should say the third piece of information, the opposite side from the angle is way too big to swing back. It's larger than a 90-degree triangle, and it's larger than the other side, so nope, there's no swinging for this guy. He does make a possible triangle. This case is fine, but he's not going to have a second. Car.
So there cannot be negative angles.
Not in a triangle. So then we just need to finish off solving for little side C. Little side C. Using a very similar formula than we were doing earlier. Give me a little fraction bar. Some of you have already found it, that's perfect. I'm just going to use your knowledge in 1 second. Because we're going to have our sine of 42, well, I'll do 22. Over sine of 42. Using our original angle A inside A. And then we have our unknown angle C over our sine of our unknown side C. Over sine of our unknown angle. 116.59. Help me out. Was it really a 4 or did it round to a 4? So it would be 3, dot. And so what you guys gave was side C when you didn't round when you plugged in? 29 point what? 400? Oh, that's quite nice, isn't it? Only one possible triangle, and there it is.
We have to write the zeros, or are they just redundant?
It's not degrees, right?
Oh, I wrote the degree mark, that's silly. No, it's a side line. Thank you, John.
Figures?
Andrew, I was proving the point that I didn't just randomly start rounding on tenths for someone who gives us.
Yeah, but.
You're fine knowing homework
Yeah.
if it's even to leave it.
Could a side length be negative? Like if it's like in quadrant 3 or?
No, because we're not establishing these triangles in an XY Cartesian plane. We're just talking about it in the real world.
Oh.
And so we're not measuring the sides in reference to anything. Does that make sense? So even in the unit circle, technically the triangle lengths are never negative, but their position makes it so that we label it with a negative, the length. So we're just looking for lengths alone. Kyle, what was your question, Ben? Okay. So what if I were to give you this one? Woo! No picture, go. Oh, stop! This formula looks fine.
It's the same thing.
Fine. Just plug in the log sign. Why are you stressing?
This stress keeps you alive.
Okay, so I got 27, 28,
Okay.
77.
Could we seem demanding?
There's two different possibilities.
Is this ambiguous, please? Yes or no? Gotta plug in the log signs, but when you plug in, you're missing an angle, which means it's ambiguous. You are missing an angle, which means it is ambiguous. So that's okay. Wouldn't the math tell you to check two cases when you go to the sign inverse place? Because the only way to solve for angle B is to get the sign B alone. So when you get the sign B alone, the only way to get B alone is to take a sign inverse. You guys agree?
Inverse that and decline the top.
And with log signs,
I'm not be wrong.
when you're thinking about needing to take sign inverse, hopefully your brain will soon and very soon, if not already, immediately jump to, ooh, I had to check two cases. One case just using sign inverse to solve. The other case using 180 minus sign inverse to solve. Oh, there's an error
Yeah,
from the beginning?
Yep.
yeah.
So we try to do 20 sine of 76 in degree mode divided by 18. It's not a legal sign value.
What if we do 10 and 9?
Square?
Divided out by 3, wouldn't that be the same thing?
Huh?
So what's the struggle? You ready?
It's broken.
For those of you that's trying to draw it, 76 would be a fairly high angle, right?
Yeah.
The opposite side is 18, that'd be the 18 over here. B is 20. I'm going to leave off the 18 for 1 second, and let's just pretend he's a right triangle for a second. If he's a right triangle, what would this other side be? Why am I asking that? To make a right triangle, the shortest distance between 2 points is a straight line, aka the shortest opposite side to 76 that is possible to make this a triangle will be the one that perpendicularly hits the base. So, if I see this, or if I can find this third side as though we're a right triangle, that's the shortest possible third side that can even connect. So I would use the sine value. Sine of 76 equals x over 20. Opposite over hypotenuse. If I solve for x, the shortest possible angle, not angle, sorry, the shortest possible side opposite angle A, which would be side A, would be 20 sine of 76, which ends up being, let me quit out, 20 sine of 76, some of you already beat me, it is 19.4, 19.406. What's the problem with the A they gave you? 18 is not big enough. If you had these pieces and you got your angle and you got your 20, the poor little 18 can't connect. He's been an angle for my visual people. How do I know? It's the shortest possible way to connect this 20 with this base of 76. I need 19.406 at least. which means that's illegal, which means this is not possible. Remember some geometry every now and then? These three pieces of information do not make a possible triangle. This is a case or a situation where there are 0 possible triangles that will result. Did the math tell you that? Did the formula tell you that? Yeah. You plugged in and what'd you get?
Nothing.
Error. And what's 180 minus error? It's still an error. No cases work. Not a possible triangle. What about this guy?
Is that 3? I thought that's 3 over M.
31 is too bad.
31. M is just meters. I'm just telling you like an actual like. Maybe it's like an application to a word problem. You're actually measuring things. A is 12, B is 31, A is 20.5 degrees. Some of you like drawing pictures, you can do that. Some of you like going straight to the formula, you can do that too. So for some of you, the visualization is going to help you remember, but for others, just plugging in the formula, you should naturally be getting the feel for when the ambiguous case is happening in log science. So hopefully every time you're like, oh, I have to do sine inverse, you're like, oh, better check 180 minus. You guys agreeing so far? You guys figured out at least if it's 0 possible triangles, 1 possible, or 2 possible? 2. Nice. There are 2. Was the first one 64.78?
Yes.
So what was it, 3 or 4? I can't see all my decimals. 3? 115.217 was the other possible B, right?
Yes.
94.717
Yes.
corresponds, and 44.283 corresponds. You can know there are 2 possible triangles as soon as your second option, your alternate version of angle B, plus the original angle A. As soon as that is less than 180, booyah, I have 2 possible cases. As soon as my second angle C is not negative, booyah, I have 2 different cases. But we're right there, all I have to do is finish. Make sure you guys are getting the exact same decimal places as I am. Because if we're all waiting to round until the very end, as far as for our side Cs, all of our answers should perfectly match. What'd you guys get for the first side C? I think I got 149. Careful, make sure you didn't round.
So you don't.
Well, you don't put the rounded angle in. You go steal the angle with all the decimal places when you're inputting it. Does that make sense?
But then if you put A, B, C,
Well, when you answer B and C, answer with the rounded, but don't plug that into your calculator. Use the other one. What'd you guys get for the last C? Point what? Great job, kiddos. Finish up section 6.1. Homework for tomorrow. Bye, guys. Have fun. Take your calculator home.
Are you actually gonna go?
Yeah, we're gonna run.
Nice,